Okay, this is a section 1.2, 1.3 pre-video. These are materials or items that are considered review for Math 136, but we cover them anyways just to kind of get everybody up to speed and on the right path to hopefully being successful this semester. So section 1.2 has two parts, exponents and radicals. We'll be covering exponents in this video and radicals will be covered at a different time. We'll do it later on within the next 2 weeks. So exponents, to remind you of what that is if you have a base and an exponent, it means that you are multiplying the base times itself a number of factors, and the factors, in other words, how many times you multiply, is represented by the exponent. For example, this is the definition that the book gives. They show you how you write this. A cubed is a to the third, so you write that 3 times. Most of us are more familiar with a base that's a number. So 2 to the third would be 2 times 2 times 2. You work this in pairs, so 2 times 2 is 4. Times 2 would be 8. So 2 cubed is 8. Now we do have some properties that we need to remind you of from exponents. This would have been covered in both 023 and Math 100, so prior classes for this. The first two are special cases of ones that most people have to memorize. These both showed up on the pre-assessment that we gave you. Anything to the 0 power is 1. The reason for this one actually boils down back to another property that's down below. If you have the same thing on top and bottom of a fraction, we know that that is 1. Anything over itself equals 1. Later on, you'll see in the next chart down that we learned that if you have the same base on top and bottom, you subtract the exponents. If you subtract 5 minus 5, you actually get x to the 0. So because these are the same thing, this has to also equal 1. The thing to be careful about with this is that notice that this is just 3 to the 0, so that's 1. This is negative square root of 2 to the 0, but notice everything is in a parentheses. If this had been negative square root of 2 to the 0 written like this, no parentheses is here. This actually means that this does not include the negative sign. So that would actually end up being negative 1. If you have a negative exponent, that means that you are locating the base in the wrong part of the fraction. So naturally, most things are written over 1. So if you have a to the negative n, that means that this a base is in the wrong location. So we flip it to the bottom and we change the sign of the exponent to say that it has now been moved to the correct location. So a negative exponent just means that your base and the exponent attached to it are in the wrong location. And anytime you move between one location or the other, it just changes the sign of the exponent. So 5 to the negative 3 would be 1 over 5 to the third, and negative 3 to the negative 5 would be 1 over negative 3 to the fifth. Notice the negative 3 did not change signs. That's because the base does not get affected when you do this. It's only the exponent. So the base just stays the same base. The exponent moves the base with it and changes signs. Okay, so this is a review of properties that you would have covered in a previous math class, hopefully. These are called our exponent laws. And the big ones are that if you multiply same bases together, we add the exponents. If you multiply a base, or excuse me, sorry, I said that wrong. If you raise a base to a power and then raise it to another power again, then you multiply the exponents. So I'm going to give you examples of both of these out here. So like x squared times x to the third is x to the 2 plus 3 more, so that would be x to the fifth. Whereas this says we're having x squared and we cube it, which means you write x squared 3 times. That's 2 plus 2 plus 2, which is x to the 6th, or you could have gotten that by multiplying 2 and 3. If you have multiple bases inside, as long as they're connected by multiplication or division, then you can apply the power outside to everything inside. That is not true if there is adding or subtracting inside here. If you have a base that's not the same on top and bottom, you subtract the exponents to figure out what the remainder left over is. For example, x to the fifth over x squared. We can think of that as 2 of these cancel with 2 of those, or 5 minus 2 is 3. Where that gets a little tricky is when you have more on the top, more on the bottom than you do on the top. So 2 minus 5 would be negative 3. Instead of worrying about negatives, you could just say, oh, there's more in the bottom, so that means the x to the third is left in the denominator. Okay, so let's look at some examples with exponents. The rules say to simplify an expression involving powers of real numbers means to change it to an expression in which each real number appears only once and all exponents are positive. Okay, so we're going to walk you through what that means by actually looking at some examples. And we assume that all of our denominators are always non-zero real numbers. That means we don't want to divide by 0, so we're just assuming that the variables are not 0. So then look at this first one here. Okay, so we have this parentheses times this parentheses. As long as there's no powers outside here, you can go straight to multiplying. So since there's no exterior powers on the outside of the parentheses, we can go ahead and say, okay, 3 times 4, I'm just regrouping. And then we'll have x to the third times x, because those are both bases that are the same, and y to the fourth times y to the fifth. So 3 times 4 is 12. This is 3 plus 1 more x, so that'd be x to the fourth. And 4 and 5 more would make 9. So 12x to the fourth, y to the ninth. Then let's look at our next one. This one has a power on the outside. Because everything inside is all multiplication, we can apply that to everything inside. So this would be 2, and 2 does count as a base. 2 to the fourth, a squared to the fourth, b cubed to the fourth, and c to the first to the fourth. 2 to the fourth is just 2 to the fourth. You don't need to multiply 2 times 4 together. First of all, this is a base and that's an exponent, so that wouldn't make sense anyways. So 2 times 2 times 2 times 2 is actually 16. These are both exponents and they're both on the same base. So this is the multiplication rule, power, power. So this would be a to the 2 times 4, which is 8. 3 times 4 for the b, so that'd be b to the 12th. And 1 times 4 for the c part, so that would just be to the 4th. So the final answer is 16, a to the 8th, b to the 12th, c to the 4th. For c part here, we have to be a little bit more careful. First of all, the reason for that is there are exponents on the outside. So you cannot multiply this top times this top yet. You need to simplify each fraction first as much as possible before you multiply. That's just the order of operations. So please excuse my dear Aunt Sally, says I need to deal with this exponent part before I can multiply in between. So we're going to work with, this is 2 squared, r to the third squared, all over s to the first squared, times, on this fraction we need to apply the 3, so s to the third over r to the third to the third. 2 squared is 4. R to the 3 times 2 would be 6. S squared would just be s squared. And I know my s's sometimes look like 5, but these are s's. And then this is just s to the third on top. And 3 times 3 would be r to the ninth on the bottom. So if we write this just, when you multiply fractions, this is a review of that. You multiply top times top, bottom times bottom. That would just be written across as this is everything on top, this is everything on bottom. And then we have to ask ourselves the question, is it reduced? If everything's multiplication or division, there should only be one of each variable. So notice that this 6, R6, can cancel out with some of the r's in the bottom. So that would be 4 on top still, because there's nothing to cancel it out with number-wise, or to reduce it with. And then we have, this would be r to the third on the bottom, because we would cancel 6 of these with 6 of those. We have more s's on top, and in fact we have one more, so it'd be a 4s to the first over r to the third. It is not necessary to write the first power. It is understood that it is there. Okay, and then let's look at this case. This one has some negative exponents going on. Sometimes it's better not to deal with those right away, so I'm going to apply this power rule first. So I'm going to apply the -3 power to everything inside. And then we can use our multiplication rule for power, power. -2 times -3 would actually be +6. 3 times -3 would be -9. And in any time you're simplifying an exponential expression like this, You have to make sure you have no negative exponents in your final answer, so we need to move the v to the 9th to the bottom since it has that negative exponent. So u to the 6th over v to the 9th. This next group is just saying that if you have negatives on top and bottom, both your bases have negative exponents, the whole fraction just flips. Also, if you have a negative exponent on the outside, you could just flip the interior fraction and change the exponent on the outside to a different sign. Be careful with this second scenario. If you do this, you don't change any exponent signs inside. You're literally flipping this whole thing, no matter what it looks like, to take care of the negative exponent on the outside. So I'll show you one of those in part B right there. Okay, so let's look at A. 8 divided by 4 will reduce, so that would be a 2 over a 1, so that would just be 2. I would go ahead and move this x up here, so this would be x to the 3rd times x to the 1st. This y to the negative 5 needs to move to the bottom, and we also still had a y squared in the bottom. Notice the only ones that move are the ones that have the negative exponents. This would become 2x to the 4th over y to the 5 plus 2, which would be 7. Okay, in this scenario, because there's a negative on the outside, one thing I can do is flip the whole fraction inside. When you do that, you don't change these to negative exponents. The whole inside is being flipped as is to take care of the sign on the outside. So this would now become a cubed, and it's a positive 3. So then we cube everything. So 2 cubed v cubed over u squared cubed. 2 to the 3rd is 2 times 2 times 2, so that would be 8. This is v to the 3rd, and 2 times 3 is 6, so u to the 6th. And that's our review on the laws of exponents. The next part of this section is section 1.3, Algebraic Expressions. I split this up so that some of the more basic things come first, and then we'll work on some of the harder concepts on our class the next time. So to remember what an algebraic expression is, you have to remember what the word polynomial means. Polynomial means many terms, and a polynomial is just a bunch of numbers and letters and possibly exponents that have been put together and then added or subtracted together. So things like 3x squared minus 2y to the 5th plus 7 is actually considered a polynomial expression. The numerical coefficient of each term is the number in front of the variable part, and it is called a coefficient. If you have just a number like this 7, that's called a constant. This is a polynomial because it's a bunch of numbers and letters connected together, possibly with exponents, by addition or subtraction. We write them in descending order, so this is actually not in descending order. If you want to do this in descending order, we would want the highest power to go first. Now, that you could argue that this is in descending order if you worry about the alphabet, because we would exhaust all the x's before we do the y's. But if we had something like 3x to the 4th minus 7x to the 5th, this is definitely the same variable, so the x part with the 5th, because that's a higher power, would need to come first. So this would be descending order, the second one here. A monomial is a single term, so something like just 3xy. That's not got any adding or subtracting. A binomial is two separate terms, so like x plus 3. And a trinomial is something where you have 3 terms. And that's a 2, sorry. Each term of a polynomial has a degree. That means what is the power on the exponent. This is a degree of 2, a degree of 1, and a degree of 0 because this one has no variable. So if you want the degree of the term, you just say, okay, depending on if there's multiple variables, like if you have a 3x squared and a y, the degree of this term is actually a 3 because it's 2 for this and 1 for this. The degree of the polynomial is the biggest degree of the whole polynomial. So if we had 3x squared y plus 2x squared minus 7x plus 3, this has a degree of 3, this has a degree of 2, this has a degree of 1, and this has a degree of 0. So the highest degree all over the whole thing was a degree of 3. So individual terms can have their own degrees, and the polynomial as a whole has its own degree. If you want to combine polynomials, there's a couple different things. You could add or subtract, but that means you're combining like terms. Like terms means you have same variable with matching powers. So an x squared cannot be added to an x cubed. Even though they have the same variable, they do not have matching powers. And subtraction is just when you do the opposite of adding. So if you had plus 3, subtraction would be like minusing 3 from that. So we'll see some examples of this. Usually we just distribute that negative and change the whole problem to just adding the opposite. Multiplying polynomials we'll also go over in this video. That means that we are distributing. The distributive property says that if you have something on the outside of a sum or a difference, if it's being multiplied by the whole thing, another way of doing that is multiplying the outside by each part inside. So this would be AB plus AC. FOIL is just a special way of multiplying two binomials together. We'll talk about that when we get to that example. It stands for first, outer, inner, and last. Honestly, you don't need FOIL. You can just distribute, but FOIL and distribute are kind of the same thing. We just give it a special name to help students remember it. The big one that students most of the time miss, and this was on the pre-assessment, is when you have to square a binomial. If you're trying to do x plus 2 squared, you do not square everything inside. This is no longer following the exponent law because there's a plus in here. This means write this twice and multiply. So you have to write it twice and then multiply it out. You don't need to memorize these formulas. These are just patterns. You can just distribute it. There is something interesting when you have two binomials that are the same except for they have different signs in the middle. They will actually have some things cancel out when you try to multiply. This will be more important in the next group of sections that we do because we'll have to talk about undoing this, which is factoring. And then dividing means that you divide, if it's by a monomial, because that's the only kind we're going to look at in this section. So you say something like 3x squared plus 3x minus 7 over 2x. You're trying to divide by a singular term. So you divide each part by that term. Later on, we'll teach you how to divide if you have a bigger thing than this in the bottom, so like a binomial. Okay, so let's look through these examples. This first one is a subtraction case. We are going to change that to the opposite, so we're going to distribute that negative to that second parentheses. So this would be negative 8x squared. Negative times negative would be positive x. Negative times negative would be positive 2. We look for like terms. The x cubed is by itself. The x squareds go together. The x to the first powers go together. And finally, I don't have any other colors, but I can do negative 2 and positive 2 go together. So this would be 6x to the third. Negative 2x squared, take away 8 more, would be negative 10x squared. Positive x plus another positive x would be 1 plus 1, so that would be 2x. And negative 2 and positive 2 actually cancel each other out. They make 0. For part B, we need to do the distributive property, and we also eventually will have to do some addition. So this is actually a combination of adding and multiplying. Because of order of operations, you have to do the multiplication first. So FOIL means that when you have two binomials multiplied together, you do first times first. So 3u, this is just distributive property essentially, times u. And then we do 3u times 2. That's going to be a separate term. So notice I put a plus sign between them. Then I need to do negative 1 times u, so that's a separate term. And then negative 1 times 2. Plus, because I have this second piece here, I will then need to distribute this. So 7u times u and 7u times 1. 3u times u would be 3u squared. 3u times 2 would be 6u. This would be negative u, or negative 1u if you want to write the 1 in. Negative 2, positive 7u squared, and 7u times 1 is 7u. My like terms, I have some squared ones that match. I have some things that are just u to the first. And then I have this negative 2 that's left over by itself. So 3u squared plus 7u squared is 10u squared. 6u minus 1 would be 5, plus 7 would be 12. And then the minus 2 gets brought over. C part is just a distributive property now where we have a trinomial. So we need to do everything in the binomial times everything in the trinomial. So 7x times x to the third plus, because we're going to have a separate group for this next pair, 7x times negative x squared plus 7x times 6. I write minuses for all of these, but if you're careful and you're worried about, okay, how do I know if it's plus or minus, you can always write plus and then include the sign in the parentheses to multiply. So plus negative 4 times x cubed plus negative 4 times negative x squared and negative 4 times positive 6. This would be x to the first and x to the third, so that'd be 7x to the fourth when we multiply. This is negative 7x to the third, because it's a 1 plus 2 more, plus 42x minus 4x to the third, plus 4x squared. That would be minus 24. Okay, so I do not have anything that goes with 7x to the fourth, so it just gets brought over. I do have some cubes that match, so negative 7x cubed and negative 4x cubed. That would be negative 11x cubed. I have an x squared that would come next, so 4x squared. I have a 42x, so I'm going to have to write that underneath, and a negative 24. So I ran out of a little bit of room there, but we would write this all on one line. So none of those can be added any further because they're no longer like terms. For the division one, if it's just a one-term thing in the bottom, in other words, no plus or minus down here, the easiest way to divide is to split this into separate fractions, where each one of them gets the denominator. You use the sign in between the terms to determine what the sign of your fraction is going to be. So we just split those up. Then we reduce. So 3 goes into 6 twice. 1a cancels with one of those, so we have a squared. 1b, or 2b's cancel with two of those, so we just have b. This is all over 1 now, so this would just be 2a squared b. 3 goes into 9 three times. One of the a's would cancel completely, and both b's cancel out, so this would just be minus 3a. 3's cancel out completely, a's cancel out completely, and we are left with just 2b squareds on the top. So that would be the answer to that one. This one is just a FOIL property. So x squared times x squared is x to the fourth. X squared times negative 16 is negative 16x squared. 1 times x squared is 1x squared. 1 times negative 16 is negative 16. So this is x to the fourth minus 15x squared, because we add the negative 16 and the 1. Remember, opposite signs, you really subtract and take the sign of the one that's farther from 0. And then minus 16. Which brings us to our final example for this video, and it's being squared. So we need to remember that that does not mean you always just square everything inside. That only works if everything inside is multiplying or dividing. Because of that plus sign inside, we can no longer use that property. So we have to write this twice and multiply, which means FOIL since it's two binomials. So 2x squared times 2x squared. When you have multiple things going on, do piece by piece. So 2 times 2 is 4. X squared times x squared is x to the fourth. 2 times 5, because we did this one, so now we're doing this one, would be positive 10. X squared and y squared are different variables, so you cannot put them together in terms of combining. You just write them side by side. This would be 5 times 2, so that's 10, and you get another x squared and another y squared. I always just write them alphabetically. And 5 times 5 is 25, and y squared times y squared is y to the fourth. So final answer is that the middle terms actually can be combined since they both have x squared, y squared. 10 plus 10 would be 20. I do want you to note something. When I did 2x squared times 2x squared, I did 4x to the fourth. I changed the exponent. That's because we were multiplying. When you add something together, you only change the coefficient out front. The variables stay stable. They do not change. That is just the difference between adding and multiplying when variables are involved. So I hope this was helpful. This has been a review of some things that are supposed to be pre-136. And like I said, we will have a worksheet on this. So bring your notes, have them filled out, and I will see you guys in our next class meeting.